Assalamu alaikum. Good afternoon, everyone. Bismillahirrahmanirrahim. Salatu wassalamu ala Rasulullah wa ala alihi wa sahbihi ajma'in. So already we are getting tired. Today I would like to present one of my research is satellite-based analysis of particulate organic matter and its physical and biological drivers in the Arabian Gulf. So the outlines of today's presentation, motivation, objectives, materials and methods, results and discussion, conclusions. Firstly, we would like to focus on the motivation of the study. In the last presentations and keynote speakers delivery, we came to know that Arabian Gulf is a very important ocean waters in this region. And the particulate organic carbon we know is present in the particulate matter, in small organic and other materials in the seawater. And we know the ocean acts as a significant sink for the carbon dioxide, and it's sequestering as approximately around 25.30% annually. And although the marginal seas are very small, around 7% as compared to the open ocean, but the objectives of this study to focus on the spatial and temporal variability of particulate organic carbon across the Arabian Gulf, and its stems of particulate organic carbon and the main biological product is chlorophyll, and the physical parameter, we know the sea surface temperature. And finally, our target was to check the connectivity between the particulate organic carbon and the physical parameter, that is the sea surface temperature, and the biological parameter, that's chlorophyll. So, if we focus on the study area, as Professor Aminul already mentioned about the diversity and the importance of this ocean is really very much important due to its unique location in its subtropical high region and low rainfall, and also due to the high salinity. So it's really, it's very much important sea waters in this region. And the data we used here is the MODIS Aqua, and it was for 2 years, from 2003 to 2023. This was monthly data, and this was of 4 kilometer resolution. It's really a high resolution in this type of analysis. So here we used a very simple modeling, you can say it's a geographically weighted regression model. It's like a multilinear regression, but it's different than multilinear regression in this case, that this the coefficients which we got from this modeling it can vary spatially in terms of picture. As much as the resolution will be higher, your number of coefficients will be higher, and which will help you to find the specific, the location-based analysis or dependency of each and every correlations. So firstly, we would like to present the time series of particulate organic carbon, sea surface temperature, and chlorophyll. Here is a very clear indication that particulate organic carbon is in a declining trend from 2003 to 2023. And in case of chlorophyll, it's also a declining trend. But for sea surface temperature, there is an increasing trend. And in case of yearly change, we can see at the beginning of the year, it's called particulate organic carbon, and the chlorophyll has a higher in the starting of each year, and it's increasing gradually. And by mid of year, it was in the highest level, and then it's going down again, something. And so particulate organic carbon and chlorophyll, they are showing the similar trend, but SST, that sea surface temperature, is showing a bit opposite pattern. You can say it's an inverse pattern. So at this stage, we look about seasonal variation. Here you can see there's in case of particulate organic carbon and chlorophyll, the high amount was found during the winter, but is lower in summer, and in the spring and autumn there is a intermediate amount we found. And in case of spatial distribution, we also see that in winter the density was higher, but in the winter, in the summer, it was lower. So the connection can be due to the dominance of small phytoplankton and other issues due to the low temperature and limited light availability. And vice versa, in summer, the high amount of light availability, and also can happen due to the the particle mixing probability is related to some geological analysis and microbial analysis. Anyway, so here we wish to check the spatial trends of particulate organic carbon, as here particulate organic carbon is the main parameter of our study. Here we see that there is an increasing trend, mostly during its amount from 5.90 milligram per meter square per year. Actually, here we use around 20 years of data, and then we get this analysis. It's really statistically significant. You can see the p-value for each application is just around 0. But in case of sea surface temperature, you can see there is a increasing trends. It's was around 0.31 per 0.31 degrees centigrade per year. Finally, we would like to check actually the relationships between the particulate organic carbon and the biological, that is the chlorophyll, and the physical parameter, that is sea surface temperature. In this modeling, actually we did in large scale, and also we have lots of layer results and spatial distributions. And due to, as this work is not published, so we did not share lots of results here. There's a final focus. You can see in the for the year 2005, the particulate organic carbon and chlorophyll, it shows a positive coefficient is around 97.03. But for the particulate organic carbon and sea surface temperature, you can see it's a negative of 3.02. So here it means that for each and every change in chlorophyll will make the increase of 97.03 milligram per meter square. It's overall, we can say, in case of all the spatial distribution, but can be varied. This was not shown here. And for sea surface temperature, that means with each and every increase in sea surface temperature can decrease the amount of particulate organic carbon by 3.02 milligram per meter square. It's really interesting, and is an issue of concern that if it is really happening, then what would be the future of the Arabian Gulf waters in terms of biodiversity or something like that. So for 2010, 2015, 2020, and also overall, each and every showing that it's around 100 milligram per meter square decreasing, increasing in particulate organic carbon for the increase in chlorophyll, but inversely, there is a decreasing in terms of each and every degree of centigrade is around 7.21 milligram per meter cube. It's really interesting and also is a matter of concern. It's a significant amount. And also, you can see the model fit R square is also around 0.88 to 0.96, and overall is over the 90%. So our model shows that the predicting capability of particulate organic carbon in terms of the physical and biological parameter is really statistically significant. So in this modeling, actually we would like to expose this. We need to make some real time, you can say, measurement from the Arabian Gulf's water to check what actually will be happening. And that's why we are working in FUSA. We have planned to make some in situ analysis to make this modeling in real time. So in concluding remarks, we can say is really the significant internal variability in particulate organic carbon, chlorophyll, and sea surface temperature. And in the important sea area, that is the seawater Arabian Gulf, as I saw from yesterday, up to this, lots of study is happening in Arabian Gulf. So now it's worth to indicate the importance of Arabian Gulf. Anyway, the positive correlation between chlorophyll and biological parameters, and there is an inverse correlation between physical parameters, that is sea surface temperature. So to enhance the reliability of these findings, further research incorporating in situ measurements, extended satellite time series data, and detailed patient analysis is recommended. And I'm thankful to Dr. Ayman Abdullah, the Director of Interdisciplinary Center for Aviation and Space Exploration, and my supervisor, Dr. Roman Schulz, for their sincere suggestions in this work. And that's all. Thank you very much.